4.5 is about dilations. A dilation is when an image is enlarged or reduced. The scale factor determines how much is enlarged or how much it is reduced. So this is your number in which the image is multiplied. To find the scale factor, it's your moved over the original. And we'll talk about that with example 1. The thing with a dilation to note is, unlike other motions, a dilation does not preserve distance, aka the objects are not congruent. So the angle measures generally are preserved, but the side lengths are not, because you're multiplying your side lengths. So this is not considered a rigid motion. However, it is considered a transformation or a motion, just not a rigid motion. So example 1, determine the scale factor. So it's the moved, aka the prime, over the original. So the prime in our situation is 4, and the original is 10. So we just reduce that to be 2 over 5. Example 2, you're just taking your values, A, B, and C, and you're multiplying them by 2. So B is 1, 1, or sorry, A is 1, 1, B is 2, negative 1, and C is located at negative 2, 0. So just a straight multiplication, A prime, B prime, C prime. So you're just, again, multiplying everything by 2. And then you're just graphing those locations. Ta-da. So we can see here, obviously, the distances are not preserved. It's multiplied. It makes sense. Since we're multiplying by a number that's larger than 1, this is considered an enlargement. Pretty straightforward, but just got to make sure I cover that. Example 3, we're going to have a reduction because we're multiplying by our scale factor is less than 1. So, once again, determining your A, B, and C values. So A is at 0, 4. B is over here at 4, negative 4. And C is at negative 4, negative 4. Prime values, once again, just multiply by a 4th. Notice these are all nice points to multiply by a 4th. You're welcome. And then we just graph those locations. And so we can see that this is a reduction. And last but not least, example 4, determine whether this is an enlargement or a reduction. When going from figure A to figure B, determine the scale factor. Well, looking at this, going from A to B, I can see this is an enlargement. And we're supposed to figure out the scale factor. It doesn't ask you to figure out X, Y, and Z distances, but we're going to anyway. Good practice there. So we have B over A, and I'm going to associate the 2 and the 5. So I have 5 over 2. So in order to figure out your other values, you're just setting up a ratio or a proportion. So if I have 5 over 2, and I want to say look for X, well, 5 is associated with the 7.5, and X is associated with the 2. So I just need to go through and cross multiply divide. So I have 2 times 7.5 divided by 5 equals X, which also happens to equal Z. When I go through that, X and Z both equal 3, and Y we also know is associated with the 2. So there's some other information on that.